ZeroMQ is an open source universal messaging library written in C++, and it's designed for high performance asynchronous messaging. In this video, I want to go through this beast of a library. I'm going to talk about the following topics. And as I'm gonna discuss this, guys, you can see in YouTube, you start seeing some chapters where you can jump into the interesting part of the video. I'm gonna make some code. We're gonna use Node.js and JavaScript to build some queue, a very simple queue with ZeroMQ. First of all, we're gonna take some time to talk about what is ZeroMQ, why does it exist, and we're going to talk about the messaging pattern that ZeroMQ tries to solve, and the socket types that it introduces to address these messaging patterns. And it's very interesting take on things, really. And then we're going to jump into the demo part of it. For example, we're going to build a simple queue with Node.js and ZeroMQ. It's a very basic queue with Node.js. I'm going to build that from scratch. And obviously, as always, I'm going to talk about my thought about this technology, the pros and cons, because still, I thought this is a simple thing, but I was a little bit disappointed. So I'm gonna give you my take at the end of the video, and finally I'm gonna summarize the whole thing. How about we jump into it, guys? Guys, if you're new here, my name is Hussein. I discuss backend engineering and stuff. If you're interested, make sure to subscribe and like this video and check out the other content on this channel. Let's just jump into it. All right, so what is ZeroMQ? It is a messaging library. And it's very important, the word library. So you include it in your application to enable messaging. And we can define what messaging means later. But that's what it is. And it is, the moment you say library, you got to tell me what are you available in, right? What languages? And they're available in 20 languages, which is awesome. It's built in C++ and it's exposed in C and Java and Python and Node.js and JavaScript and lots of other languages. So that gives you versatility. Okay, so yeah, it's a library, right? Unlike RabbitMQ, where it's a server, you spin it up, you connect to it, and your application is usually thin. Your application is going to become fat. If you use a library, that's just known, right? So it has 5 messaging patterns that we're gonna discuss, right? One of its, pros, it's brokerless, unlike Kafka or RabbitMQ or other messaging systems where they rely on a centralized broker, and then you gotta kind of load balance those broker into like some sort of a zookeeper or something like that, right? They claim they are brokerless. Well, I added meh because to build a real messaging app, as far as we know, you still need a broker. We don't know another method. So you're going to use ZeroMQ to build a broker anyway. So saying that it's brokerless is a little bit meh. So I added that. But yeah, you can build whatever you need, right? Exactly what you need, and that's an attractive feature, right? Unlike RabbitMQ, they give you all the bloat. Kafka has all the bloat, right? With ZeroMQ, if you just want to build a simple stinking queue, you can build that, and that's it. And I don't know why nobody builds that. I just want a freaking queue. Nobody has that. Right? Even this MQ, I'm not sure why it's called ZeroMQ. Has nothing to do with queuing. It has a messaging pattern, right? And then it pisses me off when people do that, to be honest. Like, yeah, why are you calling yourself an MQ? You're not an MQ. You're pretty much a lot of stuff, as we can see, right? Maybe it started as a queue and then they changed that stuff. But anyway, right? So I'm not sure why they call themselves a message queue. It's not really queuing. It has a pops up. It has push and pull and routers and dealers and so much other features. So having it calling message queue, I'm not sure then. Correct me if I'm missing something, guys. All right, so messaging patterns. These are the messaging patterns that solves synchronous request response. So you can build a request and you can send a request and you can block the application waiting for a response. Obviously, this model's dead, guys, right? In 2020, this model's dead. We no longer block anything. We are, by default, pretty much every programming language is an asynchronous language. That means, hey, I'm going to send that request, and even if I am a single thread, I'm aware and I can be unblocking, and I'm gonna just, if the response came back, I'm gonna wake up the application and get the response. So these two are just, because the ZeroMQ is an old library, they had to obviously that, and they evolved it to an asynchronous. To be my personal opinion, they are exactly identical. If you're using like Node.js, right? It's just, yeah, it's an asynchronous. Node.js is asynchronous, right? So if you're gonna use rec or a request to make a synchronous call, Node.js is not gonna block you, right? It's just to make a request, and then yeah, it's just, you can go your own merry way and do stuff, right? Yeah, so supports pops up, which is awesome, right? It supports push pull, which we're gonna turn into a queue, like we're gonna show an example, and it supports an exclusive pair. Like if you want two threads, this is supposed to be threads, communicate with each other. Are we still recording? Yes. Communicate with each other. You can use exclusive pair, where one pair and to talk to each other, and then can exchange information between threads, right? If you're doing multi-threading, if you're into these kind of kinky things, right? Doing multi-threading and stuff like that, right? Socket types. Here are the six socket types that they provide, right? And here's my little bit of my beef with this thing, right? I don't know, man. I don't know how I feel about that, but let's talk about that. Request. So this is a type of a socket that only sends requests, right? So you connect with this stuff. You create a socket and you connect, right? And then this is the reply. So reply socket. So you can request and reply. These are like kind of male female kind of a relationship, right? This connects to this, right? So this is a server, this is a client. Similar thing with push and pull. The pull is, in this case, the client, and the push is the server. So we're pushing. Dealer is the client. I should have reversed them, huh? Dealer is the client and the router is the server, but it has a little bit more features. This is the asynchronous nature of the dealer, and that's what I think. This is exactly identical to request in case of Node.js, because Node.js is asynchronous by design, right? It's not gonna block the application, right? Unless I'm missing something. That's what I noticed while coding. Router is very interesting concept, and I really like this a lot. Router is like, you can spin up a router socket, which we listen to port like, I don't know, 7,000, and then you start connecting clients, request to routers, right? Because request is the one who making requests, right? So the request clients connect to the router server, and each request, the router will assign identity to these connections, right? And you don't have fine-grained control, as far as I know, to the underlying connections, right? So think of it as like it maintains an array of connections and assigns a connection ID to each one of them. Anyway, we're gonna that's in a nutshell what it does. I'm not gonna go through this in this video. Like, this is a little bit complex, maybe in another video, but I decided not to go through it. All right. Here's what we're gonna build. Coding, finally, right? And what I'm gonna build is, I'm gonna build a little bit of a worker server job execution application, essentially a queue, right? And what we're gonna do is the server will spin up and is gonna wait, and the worker will also spin up, and the worker is essentially a pull socket, right? And the server is a push socket. And the moment we spin up the worker, it's gonna find the server and start connecting to it. I'm gonna spin up another worker and connect to the server. Spin up a worker, connect to the server. And then the server will generate like 100 jobs. And what it will do is it will just immediately send. This is exactly like the router we discussed, right? But a little bit different. So when we connect in the server code, you don't have like an array of connections. But when you do send, Like when you send a job, like let's say I'm gonna loop through 100 jobs. If you loop and start sending these jobs, job number 1 go to the worker number 1, 2 will go to this, 3 will go to this. So start load balancing the queues. Because it's a queue, it's a first in, first out kind of a thing, right? So it will it will kind of make sure each, that's what a queue is, right? The queue is, or essentially every time a client start consuming from the queue, that job is gone. It should not go to all clients. PubSub is exactly the opposite. When I publish something, all of them should receive the same content, right? If I publish job number 1 with a subscriber model, job number 1 will be received by worker 1 and worker 2 and worker 3, right? However, queue, job number 1 better be executed by only 1. Otherwise, we're going to get into trouble. How about we jump into the code, guys? Let's jump into Visual Studio Code and start doing this thing. All right, guys, I have Visual Studio Code. I have Node.js installed. And how about we jump into it and build some simple queue with Visual Studio Code, Node.js, and ZeroMQ, right? So I'm going to open a brand new spanking folder in my JavaScript playground. By the way, check out my GitHub repo. I have every single project that I built in this repo, right? So I'm gonna create a folder, ZeroMQ, boop, create. Probably ZeroMQ is a bad idea because the package, the npm package is called ZeroMQ, and I bet that they're gonna yell at us. And I don't know why this is not working. So we're gonna rename it to, I don't know, demo or something like that, or simple queue, right? And then open this thing. All right, brand spanking new project. And here's what we're gonna do. I'm gonna build 2 things, right? I am going to build the server.js, which will basically produce the queue. And I'm gonna build a worker.js, will be with a worker, right? Where they will start receiving the jobs, right? And here's what I'm gonna do. The server, here's what I'm gonna do with the server. Const ZeroMQ equal require ZeroMQ. Very simple. And just like that, we're gonna start, let's initialize the npm. How about that? We forgot to do that. Boom. npm init -y. Shut up, I know what I'm doing. Right? And then we do npm install ZeroMQ, right? And that will install the beta version. I think that's the latest stuff we have. Beta 6, right? So this is still ongoing project. So kudos to everyone who's working on the ZeroMQ team and making this happening. All right, so the first thing we're gonna do is ZeroMQ has so many sockets. We talked about the sockets, right? So what kind of socket are we really wanna create? So we're gonna create a socket, and this socket is called ZeroMQ.push. Exactly, because it's gonna push that content to the pull clients, right? So that's the socket. How about we create a function async, because we're gonna use promises all the time, right? Obviously do run and then run it here, and then we do our thing here. What do? We await sock.bind, right? Because we're gonna listen on some port, and that port's gonna be TCP 127.0.0.1 and port 7000. That should work, right? So we use await because we're an asynchronous system, right? Asynchronous. And then we gotta do it. Console.log. The server is ready, listening on port 7000, right? Awesome. So we're ready. And here's what I want to do. What I want to do here is I'm going to accept as much workers as possible. And then once all the workers are ready, I'm going to hit enter, and then I start sending the job. So I want to start the server, but I'm going to say, okay, press any key to continue kind of a thing. And to do that, all we do is just basically do a process.standardin.once, and we can do like anything like data, right? And when we get any data, right, we call a function called send, right? And here's what I'm gonna do. This async function send will start sending the jobs to the workers, right? And the beautiful part of this is almost done now, right? So to send the jobs to the workers, so this is a stdn. So let's go through the code. What did we do so far? We listen, we're waiting, and here's we're waiting. And then while we're waiting, I am going to, before we're waiting, we're going to do, hey, console.log, press any key to start sending the jobs, right? Just like that, right? And we're gonna get stuck right here. And we want to get stuck because I don't want to send the jobs until all the workers are ready and connected to me, right? It's just to show the demo, right? And this is okay. This is the process standard in, all right? And this just will be, okay, when the moment we receive any data, immediately call the send function. And what does the send function do? The send function says, hey, console.log, about to send jobs. So it's like about to send jobs because the server is Canadian, right? And we're gonna do for let I equal 0, I less than 100, I plus plus. Send jobs. How do you send, guys? What is the socket? Socket dot send. Mamacita, look at this. It's beautiful. It's just literally just send. And what do we send? What do we send, guys? I'm just gonna send literally the job ID, right? Sending job ID. That's it. Boof. And what you might say, who's gonna get this? Because the socket is the socket. But when you do send, remember, I don't have an array of the connections. I could be connected to like a million workers. This is a little bit exaggerating, but yeah, I could be connected to a lot of workers. Send will take care, the library of ZeroMQ will jump in here and remember, oh, I just sent it to this guy. I'm going to send it to this guy now. The job that goes to this guy, right? Obviously, we're going to await, right? Because awaiting is very important. And then we're just gonna simulate because it's gonna run so fast, right? How about we slow things down a little bit? And to slow things down, we do this. This is a trick, right? Promise and then literally just resolve it immediately after the timeout of resolve 500. Every 500 millisecond, resolve it and recall yourself and keep resolving it. So this way, it's like wait. This is waiting for fill 500 millisecond essentially. That's just a little bit of trick. And then we say, okay, we send it. That's it. Sending the job. Sending. And that's it. That's the server, right? How about we go to the worker? What does the worker look like? I'm going to copy this code, paste it, and here's our worker. Socket also, but new. ZeroMQ.pull. Exactly. And obviously same thing, function run. And we're gonna call the run function here. The worker is way simpler because how does the worker work? Is we'll do await sock.connect. We're gonna connect to the TCP port 127.0.0.1 and port 1000. Remember, that's the pull. That's the worker pulling request from this from the push client from the push server, right? And we're gonna do is like okay, console.log. Connected to server. And here's the thing, we're going to use asynchronous iterators, which is a beautiful feature in JavaScript, right? Which is taken from the generator functions, really. And basically it's that message, every time we get a message from the server off socket, every time we get a message, we're going to get stuck here. The moment we get a request a request technically from the server, or is it a reply? Yeah, you can look at it a different way. Yeah, whenever we get some messages, some packets from the server, we'll enter this loop. It's not really stuck. It's asynchronous. So the main thread will be just doing its own thing and just having a pointer here, and it will wake up and comes back here to execute the rest of the code. So that's the best thing ever, right? And then we're gonna do console.log. What do? I just received information from the server here, right? So if I receive something, all I want to do is just, hey, worker received job, literally this message.toString, because I don't know what the message will say. It's just like, hey, received job, boom. That's it. I'm just going to print it. I'm not going to even send anything to the server. I already connected. I'm just waiting here, pulling, literally pulling stuff. All right, how about we actually test this stuff, guys? I'm gonna use this for the first time. Hopefully it just works. And I'm gonna spin up node, the server.js. And just like that, we are ready. We listen to port 7000. And I'm not gonna click any key, right? I am going to split here and do node worker.js, spin up one worker, and then another one, DJ Khaled, node worker.js, and another one, node worker.js. All right, we're ready. We have 3 workers doing the job and 1 server. And now I'm about to hit enter. And I want you to pay attention. Look at that. 1, 2, 3, 4. Look at that. It's beautiful. Every half a second, the server sends a job and just automatically the workers do the job like there's no tomorrow. Look at that. Everyone just receiving the job. And now this is a perfect queue. And here's what I'm going to do. I'm going to kill one of the workers. No problem. The other 2 just continue the work. Oh, let's spin it back up. Hey, I'll pick up the work. I'll pick up the slack. No problem. Look at that. Kill this guy. Spin it. Kill this guy. Now this slacker is taking all the jobs, right? Look at that. And then, oh, don't finish. Look at that. Almost done. All right. Look at that. Almost done. That's it. Done. All the jobs are done. Now here's what I'm going to do. I'm going to kill the server. Here's a wonderful feature of ZeroMQ. The workers are still alive. If you're building a raw TCP socket, those suckers are dead, right? But here's what I'm going to do. I'm going to spin the server back up and then hit enter, and they continue like there's no tomorrow. How awesome is this, guys? You realize that I killed the server, but somehow ZeroMQ library maintain a state that, okay, I'm going to keep trying to connect to the server again. And the moment the server comes back to life, I'm going to kill it again. Look at that. Jobs stop. Spin it up again. And then send. Look at that. They just keep working. How awesome is this, guys? How awesome. All right. That's it for the code. I'm going to push this code for you guys. It's going to be in the description below. How about we jump back into this boring slide and complete this course video? How about we do that? Let's jump into it. All right, guys. So we built a beautiful, simple queue. We saw the feature in ZeroMQ where I killed the workers and I spin up more workers and I killed the server. The whole server is dead, for God's sake. And then the workers just didn't die. When I spun up the server again, it went back up. So this library is badass, right? So I'm going to tell you that, right? However, is it perfect? Is it perfect though? No, sir, it's imperfect. Pros. Let's talk about the pros first before we jump into the cons. Okay. It is simple, and I again added meh because, to be fair, it could have been simpler, to be honest. I believe these socket types are a little bit over-engineered, but I'm going to talk to that when I come to cons section. But yeah, just take meh with a grain of salt, right? But it's simple, all right? It is simple. Look, you saw the code. It is simpler code. I didn't need servers. I didn't need to worry about exchanges, RabbitMQ exchanges, and channels, and I don't know what other shit, publisher and consumer and brokers, and I didn't have to deal with all that stuff, right? It is efficient and lightweight. You gotta give it that. Written in C. C is a very lightweight language, so the output of C is usually lightweight, right? Because it doesn't have any garbage collection stuff. There's nothing of that going on. I mean, yeah, in our application there is, because we built it in JavaScript, which is a garbage collected language. But yeah, it's great for some small use cases. I want a stinking simple queue. You can build one with ZeroMQ. Just does that queue. Yeah, definitely. ZeroMQ is your gal. Cons. What's bad about this? It feels over-engineered. It feels a little bit over-engineered. In my opinion, guys, all of this stuff is my opinion, and you can argue with anything I say, right? Anything I say, right, can be countered. Call me out, right? If I said anything that you don't agree with me, let's have a discussion in the comment section. I'm willing to listen, obviously. So yeah, I really think it could be simpler because I was really deceived by the word MQ. They claim that zero stands for the zero broker thing, which is okay. Bleh. All right, but MQ, man, it's not really an MQ. If it's just an MQ, I would have loved it, right? I absolutely loved it. With this, it's gonna get a score of 79 out of 100, to be honest, right? But they added all this rec and rep and then dealer and the router, and they try to do so much stuff. And I know these are contrived cases because their guide don't have examples for it. If you have a feature, if you added a feature without a use case, that means some fancy developer decided to add it to the system just because it's quote unquote hip or quote unquote cool. That's the only reason a feature exists, if a developer added it, right? There's no use case, there is no documentation, and you go read the guide. Go read the guide if you don't believe me. Routers and dealers, I don't see a use case for them, right? It's clearly made up, especially their request, and they have all these type of sockets, and they start the moment you have so much abstraction. I talked about that with my RabbitMQ, right? Rant. The moment you have that stuff, the doc becomes extremely difficult to comprehend, and that's what I run into. It's like, okay, why do we have a dealer again? What's the difference between a dealer and a request? This is asynchronous, right? Synchronous, and this is asynchronous. What? Why? Well, I thought this is a property of the language. Why would I care, right? Again, might be wrong, but it's just my opinion. It felt over-engineered. Well, you have to write your own apps, right? There's no beautiful server that you spin up and does all the jobs for you, right? Some people don't like to customize. It could be a big task if you need like an actual pub sub system, guys, right? With guaranteed delivery and all the stuff that Kafka provides, right? Kafka provides at least once, exact at most once delivery, and then exactly once delivery. You think ZeroMQ is gonna do this for you? No. If you need all these guarantees, don't use ZeroMQ. Use Kafka, right? If you can give up these guarantees exactly once, you think LinkedIn is gonna use ZeroMQ? I mean, they can, but they are gonna end up building their own app from the ground up, which is kind of useless, right? So it's a balance, guys, and you have to find this balance and just play with that stuff, right? So there, pros and cons. What do you guys think? Let me know in the comment section below. Summary. All right. So what did we learn? We learned what is a ZeroMQ. It's a zero stands for zero brokerless. That means there are no brokers. I call BS because sometimes if you're gonna need a broker, you're gonna build one with ZeroMQ, and in this case, it's not called ZeroMQ, it's 1MQ, right? Yeah, so messaging patterns, it has a lot of messaging patterns, and I love them. Socket types, so many socket types. Me, no love. I don't like that. I like only, if you just decided to be a message queue dudette, you will only have push and pull. Oh my God. I am gonna love this stuff, but so much stuff, complicated, me not interested. Maybe I just not use the rest. Yeah, I can just say that. Okay. Building a simple queue with Node.js and ZeroMQ, right? We did that stuff. We built a beautiful ZeroMQ Node.js queue. Pros and cons, we talked about the pros and cons, and we finally summarized the whole thing. What do you guys think about this technology? Did you like what you saw? Give it a like, share it with your Mozami, and I'm gonna see you in the next one. You guys stay awesome. Goodbye.